tahniah. Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, Assalamualaikum dan selamat sejahtera. Kepada semua guru-guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Okey, selamat datang ke Pusat Tuisyen YouTuber, Usaha-sama E-Didik Malaysia dan Kelab Guru Malaysia. Ingat hashtag, bermula percuma, selamanya percuma. Untuk mendapatkan keberkatan kelas pada petang ini, bagi yang beragama Islam, marilah kita sama-sama mulakan kelas dengan membaca kitab Al-Fatihah. Dan kepada yang bukan Islam, bertafakur sejenak. Al-Fatihah. Amin, amin ya rabbal alamin. Apa khabar para pelajar yang cikgu kasihi sekalian? Harap semuanya berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada petang ini. Jangan lupa untuk sentiasa isikan masa dengan tuisyen online percuma. Cikgu percaya pelajar-pelajar dah tak sabar untuk mengikuti kelas fizik Prayu khusus untuk STPM dan matrikulasi ini. Sebelum itu, cikgu perkenalkan diri dahulu. Nama cikgu, Cikgu Hapsah Ayu binti Muhammad Arifin dari PTE SMK Sultan Sulaiman, Kuala Terengganu selaku moderator pada petang ini. Bersama cikgu di studio pada petang ini juga ialah Cikgu Suryati binti Muhammad. Hai Cikgu Su. Dari PTE SMK Seri Sedang Selangor selaku host. Seterusnya Cikgu Nonaini Harun. Hai Cikgu Nonaini. Dari PTE SMK Sultan Sulaiman, Kuala Terengganu sebagai pemerhati, serta presenter kita pada hari ini iaitu Madam Rosmaya binti Mohtar. Hai Madam. Dari SMK Yuhua Kajang Selangor. Pada petang ini kita bersiaran secara langsung dari channel Madam Rosmaya. Sesiapa yang belum subscribe beliau, silalah tekan butang subscribe sebagai tanda sokongan kepada Madam Rosmaya. Tajuk yang akan disampaikan oleh Madam Rosmaya pada petang ini ialah Force Between Two Current Carrying Conductor. Pelajar dan para penonton lain dialu-alukan untuk mempelajari topik ini. Kelas ini akan berlangsung lebih kurang 1 jam. Sebelum kita teruskan kelas ini, suka cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar-pelajar yang cemerlang dan marilah kita tunjukkan disiplin yang terbaik. Sila fokus pada isi pelajaran yang akan disampaikan oleh Madam Rosmaya dan menggunakan ruang chat untuk menjawab soalan atau jika ada soalan yang hendak diajukan. Pada akhir siaran, link e-sijil akan diberikan bersama kod akses. Pastikan anda menggunakan email e-didik. Dan satu perkara baru, ada mata ganjaran kredit kerana mengikuti kelas tuisyen AYU. Anda boleh menebusnya dengan hadiah yang istimewa. Anda perlu memohon ID e-didik junior terlebih dahulu sebelum mengisi borang klaim kredit. Link untuk memohon ID e-didik junior diberi semasa kelas berjalan nanti. Anda semua boleh mengisi borang klaim kredit apabila diberi link di akhir kelas. Kod untuk klaim kredit ini ada 5 digit. 5 digit. Pastikan anda mencatat dalam kertas. Untuk meningkatkan integriti, diminta jangan share kod kelas yang diberi. Okey, nombor kod yang pertama. Okey, cikgu bagi untuk nombor kod yang pertama. Okey, cikgu bagi untuk kod ini, cikgu bagi 2 digit, iaitu A0. Okey, digit, 2 digit yang pertama iaitu A0. Okey, tanpa membuang masa lagi, cikgu serahkan kelas kita kepada Madam Rosmaya. Dipersilakan, Madam.
Me with us today. Okay, so this my slide. Okay, mic open already, my mic. Okay. Okay, so I want to show you. Okay, this is my students in my school. Okay, some of the pictures. So my full name is Rosmaya binti Mohtar. So my school, SMJK Yuhua, Kajang, and my teaching experience is 28 years old. Okay, just to share some of the pictures with you all. Okay, so and also I'm going to share with you all one of the other member in the physics team. Okay, physics team. We have teacher Ayu here. Okay, as the moderator. Okay, as the moderator below me. Below me. Okay, then also other physics team is teacher Sue. Okay, our control host. Okay, below also the down there in the screen. And the rest of the teacher is teacher Suhaya, teacher Noon, and teacher Rasida. Not here. Okay, I also want to introduce other subject in our team in academy YouTuber from maths, biology, chemistry team, and also perakaunan ekonomi team. Okay, for the maths team, the maths team lead by teacher Im. Okay, and the biology team lead by Cikgu Faiza. Okay, and the chemistry team lead by Cikgu Shahnon. And in our team also we have perakaunan and ekonomi, okay, lead by Madam Fizi. Okay, so now let's direct to our topic for today. Okay, so without further ado, so our topic today is magnetic fields. Okay, this is the major topic, and the subtopic is force between two current carrying conductors. So actually physics is not very hard. And actually if you want to motivate yourself to study physics, don't just look at the formula and whatever. You just think of maybe other situation that may motivate you. Like what are we going to discuss today is force between two current carrying conductors, right? So you can imagine as the jumping rope here done by the pilot here. That's one of the tips how to study physics. So things of the any situation that may be motivate you. Okay, so our objectives today is you all should be able to derive and use the formula. Force per length equals to mu naught I1, I2, current, I for current, per 2 pi R. R is the distance between the two current carrying conductors. Okay, so this is our objective for today. Okay, so before that, okay, because we are going to discuss on the force between two current carrying conductors. So there are two possible of how the current is direction for the two current carrying conductors. So the first one, I1, we name as the current as I1 and I2. So the first possibility is I1 and I2 are in the same direction. So the second one is they may be in the opposite direction. So if the current is in the same, we will discuss for current in the same direction first. And before we continue also, can you still remember why there is force between two current carrying conductors? Okay, previously we have discussed there is a force for if the current carrying conductor is in the magnetic field. There, it is in the presence of magnetic field. Example, the magnetic field from the permanent magnet. So today, why there is a force between two current carrying conductors? Can you relate with what the previous lesson or not? So how to relate with the previous lesson? Okay, this is what we discussed before. So the wire here experience a force due to the interaction between the magnetic field from the permanent magnet and also magnetic field from the charge that move in the carrying conductor here. The current carrying conductor is a flow of charge, right? Rate of flow of charge. So because of the interaction between the two magnetic field, so we have a force. The wire experience a force. So for these two current carrying conductor, where it is also because of the interaction between two magnetic fields, but this time the magnetic fields is produced by the wire itself. Okay, by the wire, let's say wire X. Wire Y is in the presence of magnetic field of wire by wire X, and then wire X is in the presence of magnetic field produced by wire Y. So also there is because the force between the two current carrying conductor also is because of the interaction between the two magnetic fields, but this time the magnetic field not comes from the permanent magnet, but it comes from the wire itself, the wire that carries the current itself. So let's say we do one by one, wire X first. So to determine the direction of magnetic field by wire X here, so we use a right hand grip rule. Right hand grip rule. So imagine you grip this wire X, okay. So it form the shape of the magnetic field is a circular shape. Okay, so you draw the circular shape. The circle here touch the wire Y, because we are going to determine where is the B direction that acts on wire Y here. So wire Y is in the magnetic field produced by wire X. So at this point, you draw the tangent to the circle here to show the direction of B1. Okay, to show the direction of B1. So in this direction, look at the circle here, direction of B is actually in the anti-clockwise direction. So therefore, when you draw the direction of B at this point, so it's the tangent direction is into the screen, okay, into the screen B1 here. Okay, so next, we use Fleming's left-hand rule to determine the direction of a force. So because of we have B here, okay, B, and also we have a current here, so there must be a force act on the wire Y. So what is the direction of the force? So we use Fleming's left-hand rule. Okay, remember to use left-hand rule. So the B just now from wire produced by wire X, okay, is into the screen. So therefore, you points your forefinger here, okay, into the screen, and then the current is upward direction, okay. So finally, make sure the three fingers is perpendicular to each other, and therefore the direction of force is to the left, to the left. So let's say we name this as F1. So F1. So direction, the wire Y here will experience a force to the left. It will move towards the wire X. In other words, the wire Y will move towards the wire X. Okay. So we do the same for wire X. Because wire X also is in the presence of magnetic field produced by wire Y. So we do the same to determine the force act on wire Y because of the magnetic field from wire Y. The force by wire X because of in the presence of magnetic field by wire Y. Okay, so again we use right hand grip rule. Okay, to determine the magnetic field by wire Y. Okay, so you grip wire Y. Okay, imagine you grip wire Y like this. So the direction of magnetic field is in the clockwise, anti-clockwise direction, and you draw the circle so that it touched wire Y here because you are going to determine the B direction at the tangent at the point on wire Y here. That's why we draw this circle, touch the wire Y. Okay, next step, you determine the direction of B. So this, we name this as B2, or BY also can, B2, because this is B from wire Y. Okay, B from wire Y. And to draw the B direction is the tangent to this point. Okay, tangent to this point. So that means the B2 direction is out of the screen. Okay, out of the screen. Okay, so now you have I1, flow in current X, and then we have B2 from wire Y. Okay, B2 is magnetic field from wire Y. So therefore, wire X will experience a force. So to determine the direction of this force, we use Fleming's left-hand rule. Okay, so you use Fleming's left-hand rule. So you position your hand like this. So the middle finger shows direction of current, which is upward, okay, I1. And then the B is out of the screen, B2. So this is the your forefinger, okay, point out of the screen. And make sure the three fingers perpendicular to each other. And lastly, the thumb shows direction of the F. So we name this as F2. So direction of F is towards the wire Y. So that means F1 and F2 show the direction like this. So what does this mean? This means these two wires attract to each other. Attract to each other. Okay. In the presence of we put them together, so this is the force they experience. Okay, so if you look from the top view here, if you look from the top view, so it is as if the current coming out of the screen, coming out of the screen. So shows by the dot here. Dot here means current direction, from the top view, okay, top view. So if you draw the magnetic field, so it's in this shape, okay. Just now you just show one magnetic field only. So actually it's you can draw a magnetic field, represent the magnetic field by these lines. Okay. And both wire X and wire Y, they attract each other. So they feel attraction force. Okay. So now what if the current is opposite of each other like this? So we do the same method. We do the same method one by one. Must use grip rule and then Fleming's left-hand rule. Okay. So you must know how to use these two, because sometimes in the essay question it come out. Okay. So now I1 and I2 is in the opposite direction with each other. So let's say we determine the direction of B for wire X. Okay, you grip the wire X, so direction of the magnetic field is in circle, okay, circular shape, and you draw the circle, touch the wire Y to determine the direction of B on wire Y. So the direction of B on wire Y, we choose this point, so the point is into the screen. Because the circle just now is anti-clockwise direction, so the B is into the screen, okay, tangent to this point. Okay, so next. So you use Fleming's left-hand rule. So direction of current Y is downward. Okay, here shown by the middle finger. And then B is into the screen. Okay. Then lastly, the force shows to the right. And the thumb shows direction of the force is to the right. So we name this as F1. Okay. Next, we do for wire Y. B from wire Y. Experienced by wire X. Okay, so you use grip rule, grip the wire Y. So thumb shows direction of current. This time is downward. Okay, it's downward. So therefore, the direction of the magnetic field is in clockwise direction. Make sure you draw it touch the wire X, and the B direction at point on wire X here, okay, is into the screen, because direction here is clockwise, the B. So into the screen, tangent to this point. So this is B2 direction. So this B2 direction and the I will produce the force. Okay, the wire X will experience a force because of the current carrying conductor, wire X here, in the presence of the magnetic field of wire Y. Okay? So use Fleming's left hand rule. So direction of current is upward. Okay, B is into the screen. Okay, the forefinger into the screen, B2. And lastly, direction of force shown by the thumb here is to the left. Okay, to the left. So we name this force as F2. So now can you see or not? The F1 and F2 are opposite of each other. So that means these two wires repel each other. Okay, they repel each other. So the repulsion force involved here. Okay, so if you look from the top view, okay, observe from the top view. So how to show the direction of current on the wire? So one is into the screen, out of the screen, and another one shown by the cross. So that means is out of the screen. So different direction. And the field, magnetic field can be drawn like this. Okay, this is from the top view, and they repel each other. So repulsion force. Can I? Okay, now we compare with the magnetic. Okay, before that, this is what happened. You can do a simple experiment actually, which I cannot show you here because we are at home. So I just show the animation here. So remember that if the current is in opposite direction, okay, so opposite direction means what force involved. Okay, so opposite directions means it's repulsion force involved. So if in the same direction, okay, here got typing error here. So it's same direction, it attraction force. So can do a simple experiment to see how means live or actual what happened to the wire when the current flow opposite direction or in the same direction. Okay. So now we compare with the permanent magnet. So actually they are opposite. The force is opposite with each other. Okay, so look at the first one. The first one, for permanent magnet, this one you
Okay, madam.
yeah.
Okay, madam.
Yes.
Boleh saya bagi nombor kod yang kedua?
Okay. Okay.
Okay. Okay, nombor kod yang kedua ialah nombor 3. Okay, nombor 3. Okay.
Okay, so we
Silakan
continue.
madam.
Okay, so we continue. So we are going to compare, okay, the permanent magnet and the current carrying conductor, the two current carrying conductor, magnetic field and the magnetic field by two permanent magnet. So as you've learned before in the primary school, I think, primary school or in secondary school, when the pole of the magnet is opposite direction, so what happened? The magnet attract to each other, right? But for current carrying conductor is opposite. If the current is opposite direction, okay, they repel each other. Okay, repel each other. Okay, another one, when the pole of the permanent magnet is the same, let's say north-north or south-south, so the magnet will repel each other, right? But for the current, for the force between two current carrying conductor, so what happened? If they are in the same direction of current, they attract each other. Okay, so this is one way easy to memorize how the attraction force for the same same direction of current, and repulsion force if they are opposite direction in current direction. So can relate with the is opposite sign for the magnetic field. This is the easier way to memorize. Okay, so we've done this. Next, we are going to derive the equation for the force between two current carrying conductor. Okay. So F per L equals to mu naught I1 I2 per 2 pi R. So F is this force, F1, F2. So the length is length of the wire. I1 and I2, this one, the current. And mu naught is the permeability of free space, okay? And the R is distance between the two current carrying conductors. So we do for the B1 just now, okay, B1, we name this as B1, B from wire X. B1 is the magnetic field produced by wire X. So B1 equals to mu naught I1 per 2 pi R. Okay, remember we've discussed before the formula of B for the current, for the straight wire. Okay, so B for the straight wire is given by mu naught I per 2 pi R. So we use this formula. Okay, then F for the current in the conductor, for the current carrying conductor is BIL. Also, we have derived this. Actually, BIL sine theta. So it's already it's 90 degrees to each other here, F1 and B1. So therefore, we can use BIL. Okay, so the F1 experienced by wire Y, this one F1 equals to B1 here. And I2, okay, this is I2 because I2 is current flow through Y, wire Y. So it's I2 here, not I1. Okay, then times the length of the wire. Okay, so now we substitute the B here because this wire experience a magnetic field by wire X. So that's why B1 substitute into the equation here. Okay, so we simplify the equation here becomes mu naught I1 I2L per 2 pi R. Okay, so this is F1. Okay, this is F1. Okay, now we calculate F2. Okay, for F2, okay, the shown by the blue, represent by the blue BM magnetic field represent by the blue here, blue circle here. So this time the B2 is mu naught I2 per 2 pi R because wire X is in the presence of magnetic field produced by wire Y. Wire Y, so we name as B2 just now. So B2 is mu naught I2 per 2 pi R. So it's I2 because the B comes from wire Y. Then F2, okay, experienced by wire X. So F2 we use formula BIL. So it's the we substitute B2 into here, and then this I is I1 because the force experienced by wire X. So the I is I1 times L, the length of the wire. Okay, so now we substitute B into here, so we get mu naught I2 I1L per 2 pi R. Okay, so now compare these two value. What do you find? Can you compare not? So the first one, F1, if mu naught I1 I2L per 2 pi R, and F2 also mu naught I2 I1L per 2 pi R. So they are actually equal in magnitude. F1 and F2 are equal. Okay, so therefore we can say that the attraction force is given by this F. Okay, F can name as just F. Okay, they are equal each other. And you can also represent it by saying as a force per unit length. So by what L, we bring L to the left side becomes force per unit length. Okay, means force per 1 meter length. Force per unit length. So equals to mu naught I2 per 2 pi R. So we have derived the formula for force between two current carrying conductor. Okay, so you can memorize this formula for the force between two current carrying conductors. Okay, so we've done for the derivation of force between two current carrying conductor. So memorize this formula. Remember, and the exam formula is not given. So you need to memorize, not like the form 4, form 5. Okay, for STPM, formula is not given. So you need to memorize this formula. Okay, and we have okay, and we have the
Madam.
yes, yeah, yes,
Madam
yes.
Rosmaya. Okay, rasanya kita hello.
30 minutes sorry.
Rasanya elok kita bagi laluan pada iklan dahulu.
Okay, we take a rest.
Okay, boleh kita rehat sekejap untuk bagi laluan kepada iklan. Okay, sementara tu kita boleh beri ruanglah kepada para pelajar untuk ingat semula apa yang kita pelajari hari ini. Okay.
Berita baik untuk semua.
Kini, Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okey, bertemu kita kembali. Okey, sebelum kita teruskan kelas, jangan lupa untuk menunjukkan tanda sokongan kita pada Madam Rosmaya. Okey, jom kita like, share dan subscribe dengan tekan loceng channel Madam Rosmaya. Okey, dipersilakan Madam.
Okay, welcome back everyone. Okay, so we continue our discussion today. So what we are going to discuss next is we are going to relate the force between two current carrying conductors that we have discussed just now with what we have learned before in SEM 1, SEM 1 or actually Form 4, Form 5, Form 4. So you've learned this, the definition of ampere, the SI unit. So in the Form 4, you've learned that. So until 2019, the SI unit, okay, the International System of Units, define the ampere as this one. Okay, we recall what we have learned before. So the ampere is defined as the constant current which, when flowing into infinitely long, straight and parallel conductors of negligible cross-section placed 1 meter apart in a vacuum, causes a force between them of 2 times 10 to the power of -7 Newton per meter of their length. So where this value comes from? The force here, 2 times 10 to the power of -7 Newton per meter. So this value actually comes from what we are discussed today. So let's try to get this force. So we use the formula just now. F per L equals to mu naught I1 I2 per 2 pi R. So for this force for per meter length, so we substitute the meter here, 1 meter, and then the current for SI unit. So for 1 ampere, so we substitute 1 ampere here for both two current carrying conductor. I1 is 1 ampere, I2 also 1 ampere, and the length of the current carrying conductor also 1. Then the distance here given here 1 meter. Okay, so therefore we get the force, we calculate this. So we get 2 times 10 to the power of -7 Newton per meter. So this is where the force comes from. Okay, so this is until 2019, the SI unit. So we use for definition of 1 ampere. Okay, so after the 2019, they use another SI unit definition. So that one you can find out by yourself. Okay, you can Google yourself and find out what is the next the latest definition for 1 ampere. Okay, so next we go to the next slide. It's the question time. Okay, question time. So I didn't put this question in the description part because I got no time because we have very busy teachers very busy because of the registration of the students Form 6. This week is the registration time for Form 6 student. So maybe I can put later the question we are going to discuss today. So we go to question 1 and we can do together here. Okay, we read first the question. Okay, 2 parallel straight wires that are very long are separated by 0.065 meter and carry currents of 15 ampere and 7.0 ampere. So find the magnitude and direction of the force that the magnetic field of wire 1 applies to a 1.5 meter section of wire 2 when the currents have opposite and B, the same direction. Okay, so this is a question to test whether you can remember the formula or not. So did all of you jot down the equation, the formula just now we have derived? Okay, so the formula, this is the formula. Memorize this formula. Mu naught I1 I2 L per 2 pi R. Okay, so we substitute the value of mu naught, which is 4 pi times 10 to the power of -7 Henry per meter. So 2 pi. Okay, so I1 is what? I1 is 15 ampere and I2 is 7 ampere. Okay, so it's a direct question. Just to test as a warming up exercise actually. Okay, substitute 15 ampere. Okay, 7 ampere. And then the length, the length is 1.5 meter section here, 1.5 meter section. So this is the length, the L here is the length of the wire. And then the R is distance, R is distance between the two wires. So given here, 0.065 meter. Okay, so what you get, the force is 4.8 times 10 to the power of -4 Newton. So this is the warming up questions. Okay, but remember the question asks for what if the two wires have opposite and same direction, opposite direction and same direction, the current, okay, the current. So if opposite direction, we have derived before that F for the force of wire X and wire Y just now, they are equal in magnitude. So that's mean these two wires, even though the direction of current is opposite or same direction, the force is also the same, which is 4.8 times 10 to the power -4 Newton. So you just put the sign or you just mention the direction, whether it is a repulsive force or the attractive force. So for wire XY, opposite direction, okay, they repel each other. So that's mean repulsive force. You just mention with the same magnitude, F 4.8 times 10 to the power of -4 Newton. And if it is a same direction, so the force between them is the attractive force. Okay? Okay, so now question 2 it's time for you all to do. Okay, so let's try the question here. Okay, ready with the pencil or pen and a paper with you, calculator. Then try this question. A horizontal wire carries a current I1 equals to 80 ampere. So a second parallel wire, 20 centimeter, okay, below it, okay, here, carry how much current I2? We are going to determine this I2 so that it doesn't fall due to gravity. This is a little bit different from the question 1, but actually it's the same thing. So that this wire doesn't fall into gravity. So we combine with the previous lesson actually. So it's a harder question compared to the question 1. So the lower cut wire has a mass of 0.12 gram per meter of length. Okay, so this is a mass per meter. So 1 meter length, the mass of the wire is 0.12 gram. Okay, so try to answer this question using the formula force given just now. Can remember or not? Hopefully you've jot down. And then combine with what we've discussed before. Okay, so what does it mean by doesn't fall due to gravity? Okay, what does it mean by doesn't fall due to gravity? Anyone can write there in the chat box there. Okay, what does it mean? What information can we get if the current, if the wire doesn't fall? What does it mean? Okay, it's related to forces. I give you clue already, right? Okay, can write there in the chat box to name what are the forces involved. Okay. So the wire does not fall due to gravity. So what does the force involve? Okay, so Chai Teng Xuan, okay, weight, mg, weight. What else? What is the force, other force involved to balance the weight, mg? Okay, what is the force involved? Okay, we discussed in the previous slide. Balanced by the yes. So that F, what is that F? There are two forces here. The first one is the weight. Okay, so another one is the force between two current carrying conductor. Okay, you can see from the title here, right? Force between two current carrying conductor is the same as weight. It's the same as weight. Okay, so magnetic force also correct. Magnetic force equals to weight. Okay, so housing calculate already very fast. You get, so we can check later. Did you get the same answer? Current 14.7 ampere, and very good. You answer towards the left together with the direction. Okay, so direction is given there already. Housing. Okay, never mind. We do together. Okay, so what is meant? Direction of current, or what direction there you mean? Housing. Okay, now as we discussed the forces, okay, you've written there already. So magnetic force Fm equals to mg. So this is the first step you need to write. Got marks, got marks here. Okay, doesn't fall due to gravity means Fn equals to mg. So once you write here, you get the first mark already. Okay, the first mark already. Fm equals to mg. So now the Fm is the magnetic force. So the force between the two current carrying conductor. So we substitute the force that we have derived just now, mu naught I1 I2 L per 2 pi R. Some book use D. So D also can, R also can. Okay, so the weight is mg. So you substitute the values given. Okay, so the 80 ampere, the current is, we are going to determine the current, so we just substitute SI2, and then distance, don't forget to convert to meter, 20 centimeter convert to meter, because the rest all is an SI unit, 9.81 is SI unit. And then what else? The gram here, 0.12 gram also convert to kilogram. Now everything all is in SI unit, so you calculate for I2. So you get 15 ampere. Okay. So if you like Chia housing, you write in 3 significant figures, also accept, is accept, is accepted, because all the information given is 2 significant figures. So you can, you are allowed to answer in 2 or 3 significant figures. So it's still correct, even though you answer is 14.7 ampere. Okay, so direction no need to mention because here shown already here, right? In this direction, I2. Okay. Only maybe the question asks for direction of magnetic force. So for direction of magnetic force is upward. Okay. So then, okay, we finish this question too.
Okay, Madam.
Yes.
Madam.
Yes.
Okay, kita bagi untuk nombor kod yang ketiga.
Okay, so what is the third code?
Okay, nombor kod yang ketiga ialah 8.
Okay.
Okay, nombor kod yang ketiga 8. Okay.
Okay, so we continue with the third question. Okay, so the third question, this time harder than the second question. Okay, this time involve current for a straight wire and current in the coil, rectangle coil. So we read the question together first. A long straight wire carries a current of 20 ampere. So the long one here, as shown in the figure. So a rectangle coil. So this is a rectangular coil with two sides parallel to the straight wires, has sides 5 centimeter. So here 5 centimeter and 10 centimeter. So rectangle shape, 5 centimeter, 10 centimeter with the near side at a distance. Okay, distance 2 centimeter from the wire. Here, 2 centimeter from the wire. The coil carries a current of 5 ampere. Okay, 5 ampere. Then find the force on each segment of the rectangular coil due to the current in the long straight wire. Okay, then what is the net force on the coil? So that means we need to find the force on each segment. So we have, here is the rectangular coil. So we have 4 segments. So we need to determine the force on each segment. Okay, so we do for the first segment. Okay, we do for the first segment here. The side near to the long wire here. This is rectangular coil. This is a straight wire, long straight wire. Okay, so we use the formula force on the 2 current carrying conductors here. Okay, mu naught I1 I2 L per 2 pi R. So we substitute the values given. So both I1 and I2 is 20 ampere and 5 ampere. And then the straight wire here, the length is 10 centimeter, convert to meter. So 10 centimeter, 10 times 10 to the power of negative 2 meter. Then the current 20 ampere, 5 ampere. And lastly, the distance. Distance between these 2 wire for this segment is 2 centimeter, convert to meter. So you get the answer 1.0 times 10 to the power of negative 4 Newton. So this is the first force for this segment. So we keep this for a while. And for the direction, just memorize just now same direction, opposite direction actually. Look at the direction of the current. So for opposite direction, it is repulsive force involved. So that means the rectangular coil for this side, the force will move to the right, Okay. So we keep this for a while, because later we are going to determine the net force. So we keep for a while for force 1. So we do for the other 3 segments. Okay, we do the same for the other 3 segments. So the second segment we choose here. Okay, we choose here. So what is the force now? So using the same formula, okay, F equals to mu naught I1 I2 L per 2 pi R. Okay, so we substitute the values here 10 cm, same 10 cm, 20 and 5. This is rectangle coil, right? So the current flow is 5 ampere. So 20 and 5 still the same. But the distance now difference. The distance now, this 5 plus 2 becomes 7. So 7 times 10 to the power of negative 2 meter, convert to meter. Okay. So the answer now different from the F1. We name this as F2. So 2.86 times 10 to the power of negative 5 Newton. And because the 2 wires are, the direction of current are in same direction, so that means they attract each other. So attract each other for this wire, okay, this wire highlighted with the orange color will attract to the right, to the left, okay, so it's to the left. Refer to this segment, They attract each other, but refer to this segment. So the wire will move to the left. So we keep this value of force we name as F2 for a while, and we write with the sign negative because to the left. So we define the negative direction as to the negative is to the left. Definition for negative to the left direction, because we are going to use vector later to get the net. So just put negative there. Okay, and we still haven't finished because the question asks each segment. Okay, each segment. So that means we have another 2 segments, top and bottom here. Okay, so the top segment here, okay, the 5 centimeter length. Okay, so the highlighted by the purple line here. Okay, so for this wire, what is the direction? So we haven't discussed the previous slide. So we discuss now the direction of force. So this wire also experience magnetic force by the straight wire. So the magnetic force by the straight wire here, you use a grip rule. So it is in the anti-clockwise direction, and you choose one point on the wire on this segment, and the direction at that point is into the screen. So you draw the B into the screen. Okay, not? So into the screen B. So therefore, now where is the direction of the force? So you use Fleming's left hand rule. Okay, Fleming's left hand rule. So for Fleming's
Madam,
left, yes.
ni ada pertanyaan daripada Amayo Ronald. Okay, tanya, there is attraction. So what do you determine to say to the left?
Attraction between each segment. I don't understand your question actually. There is attraction. So what do you determine to say to the left? Which segment do you mean? So the segment is just now this one. This segment, these two segment. Okay, I go back. If you mean these two segment lah. Because I not understand what you ask. Okay, for these two segment, the wire is same direction, the current. Just refer to these two segment. Okay, the question asks to find force on each segment. So these two segment, they have same direction. So if they have same direction, so that means what involved is the what involved is if two current same direction, for the force two current carrying conductor, the force is attraction to each other. So referring to this segment, this wire is towards to the left. Okay, so that's why to the left. Okay. If you mean the segment lah. So now we go to the other segment. The question asks each segment, right? So now we discuss next segment is here. Okay, the top segment here. So for the top segment, so this wire also, this segment also experience a magnetic field by the other wire here. So to determine the direction of the B, so we use grip rule. Okay, grip this wire and the direction of B, choose any point along this segment and it is into the screen. Let's say we choose here. So the B direction is into the screen. Okay, you are welcome, Ronald. Okay. So the B is into the screen for this segment. Choose any point here. And now to determine the force on this wire by this 20 ampere current carrying conductor, so we use next is Fleming's left hand rule. Okay, so the position of your hand is like this, where look at the current here is to the current is to the left. Okay, here the middle finger, and then the B is into the screen. Okay, and lastly direction of the thumb is downward. So that means the F3 is downward. So therefore, this segment, the force on this segment, okay, is to downward direction. Okay, so we've done for this segment. The force is downward. So next is we are going to determine this value of F3. And we name this force as F3. So we use the same formula, F equals to mu naught I1 I2 L per 2 pi R. Okay. So we substitute the value, same current 25, but the length of the wire this time is 5 centimeter. This segment is 5 centimeter. Convert to meter, and the distance we just mentioned SR because it's up to you to choose which point. So I generally just put SR. Can be 4 centimeter, can be 3 centimeter, in between 2 centimeter and 7 actually. 5 plus 2 is 7. So in between 2 and 7 centimeter. Okay, not? So I just simply put R here. So we get 1 times 10 to the power of negative 6 per R. Distance we choose here. So we do the same and the direction just now downward. So we put here for a while for F3 because we are going to find the F4, the fourth segment of the rectangular coil here. So we do the same for the fourth segment. Okay, highlighted by the blue line here. Okay, we do the same you grip the rule, you use a right hand grip rule, you grip the wire here to determine the direction of B for experienced by this segment of wire, and it is into the screen, right? Choose one point here, so B is tangent to this point, so into the screen again, and using Fleming's left hand rule, it is found that the force experienced by this segment of the wire is upward direction. Okay, upward direction. Okay, I repeat, we see the direction of current is this way, right? Shown by the middle finger, okay, to the right. And then the B is into the screen, the forefinger, and lastly, the thumb shows upward direction. So F4 is upward direction. So now it's time to determine the magnitude of this F4. So I1, I2 is still the same, 20 ampere and 5 ampere. And the length of the segment here still 5 centimeter, convert to meter, and 2 pi r. So r, you choose the same point as the segment just now, on top segment, top segment, and below segment. So can be at any point in between 2 centimeter and 7 centimeter from the wire. And both actually they are all these two segments they are at the same direction from the straight wire here, 2 ampere current carrying conductor. That's why we just say as R, right, generally. So you find that actually F1 and F3 and F4 is the same value, only opposite direction. So this F3 and F4 is the force experienced by these two segments in the presence of magnetic field by current carrying conductor of 20 ampere, current carrying conductor. So same value, right? So we represent as the sign negative for downward direction and positive for upward direction. Okay, and we find that actually they repel, these two forces repel each other. They cancel each other. So this F3 and F4, they cancel each other. They are equal in magnitude. So that's why for the question B, okay, we've done for the each segment, find the force on each segment, done. So we do B, the net force. So from these 4 forces, we calculate net force. So for F3 and F4, they cancel each other, so the net force is 0. And for F1 and F2, okay, these two, so you can use this one, F3 and F4 cancel each other. So for F1, F2, is you minus this, you get 7. I go back first. Okay. For F1 and F2, horizontal force, we can see that this is horizontal force. And F1 minus F2, we get 7.14 times 10 to the power of negative 5 Newton. So therefore, the net force, this one is 0, right? 0. Actually, you just no need to involve this because 0 they cancel out each other. So therefore, the resultant force is 7.1 times 10 to the power of negative 5 Newton. So I didn't put the unit here, typing error, but you can put the unit, must put the unit here. I forgot to put the unit here. And because we got positive value, and as early definition, negative is to the left and positive is to the right. So if you minus, you got positive value. So that's mean the force, net force is to the right. Positive value is to the right. Okay, not? So that's our answer for the net force. Okay. So for the question, next question, I think we don't have enough time for the next question 4 and question 5. So I will post the question in the description and make a video out of it. Okay. To the right, you can so this one I forgot to say. To the right means that the coil, the whole coil actually, because this is net force, right? So the whole coil moves away from the straight wire, because this is the net force or resultant force. So the whole coil, rectangle coil, moves away from the straight wire. Okay, from the resultant. Okay, so because we don't have time, so I will leave this question in the description part. You can do, and then I will make a video from this question. There are two questions actually. We don't have time to discuss here. Question 4 and question 5. Okay. But the most important thing is you understand how to use the formula we have discussed this now. Okay. Okay. So I think that's all from me for today's discussion. Okay, I give back to the moderator, Cikgu Ayu.
Okey. Okey, alhamdulillah. Okey, kita sudah habis untuk sesi hari ini. Okey, terima kasih diucapkan kepada Madam Rosmaya atas perkongsian ilmu yang sangat bermanfaat, mudah difahami dan sangat menarik. Okey, jadi kita dah selesai kelas untuk petang ini. Okey, tahniah diucapkan kepada semua yang setia mengikuti kelas pada petang ini dari awal hingga ke saat ini. Okey, sebelum kita tamatkan sesi siaran langsung, mohon tutup ruangan chat dan klik butang subscribe dan aktifkan ikon loceng supaya anda tidak terlepas sesi kelas yang seterusnya. Okay, sekiranya anda suka dengan apa yang dipelajari hari ini, okay, sila klik like dan share kepada rakan-rakan di media sosial anda, FB serta Insta anda untuk sebarkan ilmu dan beroleh kebaikan di atas perkongsian tersebut. Okey, sila type done di ruangan komen sebelum link sijil akan diberikan. Sebagai tanda terima kasih daripada cikgu kerana kehebatan kamu menyertai kelas tuisyen percuma pada hari ini. Okey, untuk nombor kod yang terakhir. Okey, nombor kod yang terakhir ialah nombor sifar. Okey, nombor sifar. Okey, jadi anda telah mendapat ke-55 nombor kod untuk tebus mata kredit. Link diberikan di ruangan komen. Okey. Dan pastikan anda mempunyai ID junior e-didik untuk menebus mata kredit berkenaan. Okey, link sijil boleh didapatkan pada bahagian chat. Okey, kod akses adalah #KelasAYUEdidik. Okey, sila ambil perhatian, link tersebut akan tamat tempoh dalam setengah jam selepas live ini. Okey, pastikan anda guna email e-didik sahaja. Okey, sekali lagi cikgu ucapkan ribuan terima kasih kepada Madam Rosmaya dengan kelas petang yang amat menarik ini. Okey, tahniah juga diucapkan kepada semua yang setia bersama kelas pada petang ini dari awal hingga ke saat ini. Okey, kelas seterusnya untuk tuisyen fizik Melayu adalah pada waktu yang sama pada minggu hadapan, iaitu pada hari Ahad jam 5 petang. Okey, anda semua dijemput untuk ke portal www.academyyoutuber.com untuk dapatkan jadual tuisyen dan info terkini. Bantu cikgu untuk sebarkan kelas tuisyen percuma ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Okay, usaha ini adalah hasil gabungan guru-guru seluruh Malaysia untuk semua para pelajar di seluruh Malaysia, terutamanya dalam menghadapi saat genting melawan pandemik COVID-19 sekarang ini. Okey, semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Okey, ingat hashtag bermula percuma, selamanya percuma. InsyaAllah. Okey. Okey, terima kasih kepada semua. Okey, segala yang baik itu datangnya dari Allah. Jika terdapat sebarang kekurangan dan kelemahan, itu adalah daripada kami. Okey, sehingga kita bertemu kembali di lain siaran. Okey, Assalamualaikum dan selamat petang. Okey, bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.